All right, guys, let's talk about Unit 6, Lesson 1, which is development of the periodic table. Mendeleev is the one that is accredited with determining what the periodic table would look like. He first organized the periodic table of elements based upon their atomic masses. So he looked at them all, and this is what he came up with. It looks a little bit different than what we're used to, but they were all grouped based on the masses that they had. Obviously, that's not what we now look at, so someone came in after him and changed it, and his name was Moseley. He developed what we now know as the modern day periodic table. He organized the elements based on their number of protons, which we learned in the atomic unit was called the atomic number. There's also something that came about after Moseley organized his periodic table, and it's called the periodic law. And that basically says that the properties of elements are periodic functions of their atomic numbers. So basically, he said that elements are grouped on the periodic table based on properties as well as their atomic numbers. So if you think about the calendar for like February, we group our days and write them in a calendar based on their day. So everything in this first column is Sunday, all the dates in the second column is Monday, and so on and so forth. And then this is the weeks of the month. So in February, there's 1, 2, 3, 4, 5 weeks in February. Very similar to how and what we're going to talk about when we talk about the periodic table. The results from the periodic law. So basically what we can do is when we fill in the gaps, this is an older version of the periodic table because all of these gaps actually have elements in them now, but we can predict the properties of the undiscovered elements and how they're going to behave, and based off of this grouping about what their atomic number and their mass is going to be. So how is the table organized? Well, the first thing you need to know are two vocab words. So periods is first. Those are the horizontal rows. They are equal to the number of energy levels or shells that an element will have. Then there are groups. Those are the vertical columns. So, and those are going to be those elements in those groups have the same number of valence electrons, and because they have the same number of valence electrons, they will have similar chemical properties. So here's the periodic table from page 9 in your reference table. Okay, your reference packet that you have that we gave you a couple weeks ago at the beginning of the year. So groups and periods, let's label them. Periods are going to go across, so left to right. And groups are going to go down, so from top to bottom. Let's zoom in and look at this a little more closely. So here's a zoom in shot of the top left of your periodic table. And as you can see, the period is labeled on the left-hand side. And as you go across that period on your periodic table, all of those elements will have the same number of energy levels. So if it's hydrogen, it's in period 1. So that's period 1. Period 2 has lithium, beryllium, and then the rest all the way over on the right. Period 3, sodium, magnesium, and so on and so forth. Groups are different on the other hand. Groups are going to be going down. So we have group going down this way, on group 13, group 14, group 15, group 16, group 17, and they all have the same number of valence electrons. Look at group 17. The electron configuration on your reference table tells you that. This has 7 valence electrons, 7 valence electrons, 7 valence electrons, and look at that. They're in group 17, and group 17 has 7 valence electrons in it. So we just got done talking about this, and when we looked at the unit that we just finished, which was the electron. Everything in group 1 has 1 valence electron. Everything in group 2 has 2 valence electrons. Everything in group 3 has 3 valence. 4 has 4 valence, so on and so forth. We're not going to talk about this section right here, which we will now learn to know that it's called the transition metals, because they vary in their valence shell electrons. So let's talk about the reactivity of the elements. So the reactivity, how reactive something is determined by the number of valence electrons that it has. All atoms, except for hydrogen, want 8 valence electrons to become stable or have a full valence shell. That's what we call them. And if they are stable, we are said to call them to have a stable octet. So hydrogen and helium behave a little differently. So the closer this to a stable octet the element has, the more reactive the element is. Hydrogen and helium are different because they're in period 1. And in period 1, they only need to have 2 electrons to have a full valence shell, not 8. So 2 valence electrons in 1 shell. Helium is full, it's stable, non-reactive. So let's look at the practice problem 1. Which elements is in group 2 and has 4 energy levels? Well, pause the video and try this for yourself. Okay, welcome back. So which element is in group 2 and has 4 energy levels? So if it's in group 2, it's going to be in column 2 on the periodic table. Okay, so we're looking at one of these, either B, E, M, G, or C, A. If it has 4 energy levels, it's going to be in period 4. So this is period 1, period 2, period 3, period 4. So period 4, group 2, we're looking at calcium right here. Very good. Practice 2. Which 2 elements have similar chemical properties and why? Sodium, potassium, lithium, or beryllium? Pause the video, answer this question in your notes. All right, what did you get? Which 2 elements have similar chemical properties and why? When you looked at your periodic table, you should have picked the 2 that are in the same group. And in the 2 that are in the same group are sodium and potassium. They're in the same group and have the same number of valence electrons. They both have 1, so they are going to react very similar. Check your understanding. Which element is more reactive, oxygen or fluorine, and why? And we're going to talk about this in class tomorrow when we come in. But try it in your practice packet, and we'll see you tomorrow.